Okay, so with this one, I'm looking at that third argument where we want to figure out what is the tension in this web. So what I did to do that was I took this frame and I said, okay, well, I can kind of measure some things from this frame. And I based a lot of it off of real life, like kind of some measurements that I could take. So one thing that's a little bit unfortunate, I didn't think ahead, I didn't bring like a meter stick or anything home. But what I do have just sitting here, because I don't want to go to the recycling bin, is I have a bunch of pop cans that are just kind of sitting here. I have 5 that are sitting here. And I decided to use that as a measurement tool. So I said, well, I can see Spider-Man's forearm pretty clearly here. And so what I did was I stacked up my pop cans or soda cans, and I said, okay, well, the distance from my elbow to the top of my fist is about 3 soda cans. It was a little bit more, but whatever. So I called it about 3 soda cans, and then I Googled, hey, what is the average height of a soda can, of a Coke can? So it said that it was about 4.83 inches, which then I converted to meters. So I said it was 0.122682 meters. So in total, it looks like this forearm is about 0.368046 meters. So that was really my reference point. And I said, okay, well, I'm going to draw a line here and say that this is about 0.36804 meters. And I figured out what is the radius of rotation of this manhole cover based on the length of his forearm. I'm kind of assuming that they're all in the same plane here. So I said, okay, it's about 6.7 or so, 1, 2, 3, 4, 5, 6 point, about halfway or a little bit more than halfway to the center of mass of that manhole cover. So I said that this is about 2.465 meters for my radius. So my radius of rotation is about 2.465 meters. And then I found that the radius of the cover is about 0.368 meters, but I didn't actually need that, but whatever. I said it was about the same as a forearm. Then I looked up, okay, what's the mass of my manhole cover? And it says that the average manhole cover is about 113 to 136 kilograms, so people don't steal them, because they're kind of cool. But so I just said, okay, I'm going to split the difference. I'm just going to call that 120, nice even number. Then what I need to do is kind of going down here a little bit more. If I want to find the tension, I know that this tension is acting as a centripetal force. We said that in order for an object to move in a circle, it needs this velocity that is perpendicular to the edge of the circle, and we need this inwards pointing force, the centripetal force, to keep us moving in that circular path. So in this case, the tension in that wire, in that web, is the thing that's acting as our centripetal force. So our equation for centripetal force is mv squared over r. So I found the mass of the manhole cover. I found the radius of rotation. The last thing I need is the velocity. So we've been saying in this unit that our velocity is equal to our angular velocity times r. That was kind of one of our big ideas. So in this case, our angular velocity, we can figure it out. We can assume that it's kind of spinning at this constant rate. And we know that our angular velocity is our change in angular displacement over time. So the easiest angular displacement I could think of was just doing one full rotation, so 2 pi radians. And I said, okay, this thing is going 2 pi radians, and I counted how many frames it took it to go one complete rotation. So it took about 19 frames in that video. YouTube said that that video uploaded at 30 frames per second. I don't know if that's true. It seems a little lower, but that's what YouTube said, so I rolled with it. So I said we went 19 frames. It was a 30 frames per second video. So that means that in total, one rotation, 2 pi radians, was 6.33 seconds. And then what I did was I said, okay, if I want to turn that into an angular velocity, it is 2 pi radians for every 0.6333 seconds, which means that my angular velocity is 2 pi over 0.6333. I didn't do the math for that, because what I really need was the linear velocity. So my linear velocity, I said, is the angular velocity times the radius of rotation. So my angular velocity is 2 pi over 0.6333. The radius is 2.465, which means when I multiply those together, I get a velocity of 24.45 meters per second. And now if I want to find that tension, I'm able to plug into this centripetal force equation. So again, the centripetal force, my center pointing force is the tension, and we said it equals mv squared over r. Remember that came from, it was force is mass times acceleration, and our our centripetal acceleration is just v squared over r. So I can plug in everything that I know now, and I get a force of 29,101.9 newtons, which is a very, 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 very large force, which makes sense because this manhole cover is heavy, and he needs to spin it in a circle. So that's what I found for question 3.